So, good morning to everybody. In this video, in the previous class, we saw about the problem on Gauss-Seidel method of load flow study. In this video, we are going to see a problem with a voltage controlled bus. So, kindly go through the video.
So what is the equation for Qi? Minus imaginary part. Minus imaginary part. Vi star II, or II is nothing but k is equal to 1 to n Yij. Is not it? This is the equation for that. So for I is equal to 2, we will write Q2. Or for first equation, have you assumed initial values of the variables? So values of these variables will be same as we have assumed as that of slack bus. So now we need to assume for this PV bus also. So for PV bus, variables are Q and Q2 and delta 2. So we need to assume initial value of not Q2. We have already discussed that Q is already function of V and delta. So no need to assume initial value of Q. Assume other variables and evaluate Q, right? So delta 2 only. So delta 2 you may assume as that of slack bus. So assume delta 2 is equal to 0 and other variables, that is V3 0 is equal to V4 0 is equal to 1.04 angle 0. Is not it? Yes. So right here quickly I will stop within 1-2 minutes. So Q21 will be minus imaginary part. Do you have class after this? Yes. Okay, I will finish quickly. So I is 2 now. Yes. So that will be V2 angle delta 2 minus for a star minus will be there, delta 2 0. Is not it? Yes. This is the variable now for PV buses. And Yik Vk. So how many k starting from 1 to n? So 1, 2, 3. Put the values. So take this. Y I is 2. So Y21 V1 plus I am writing here Y22 V2. Here Y2 will be there. So Y22 V2 0. Is not it? Plus Y23 V3 0 plus Y24 V4 0. Any doubt? Is it fine? So you know the values of Y21, Y22, Y23 and Y24. And you have assumed the initial values of V20, V30, V40. So instead of writing V20, we may write V2 magnitude delta 2 0. It's not it? Because V2 will be fixed. That is parameter, not variable. And V2 is given. This is variable. And we have assumed the value of initial value of this variable. So put these values. So evaluate it quickly. Tell me the value. So it is coming out to be 0. Just check it at home. Q limits are minimum is 0.2 per unit. So this Q2I evaluated is not coming under this limit. The limit is violated. That is a problem. That is a big problem. Because of this PV bus will lose its identity. The PV identification will now be lost totally because of this problem. You know the problem? Q2 evaluated at bus number 2, that was PV bus, is violating the limit. Coming out to be either lesser than minimum or maximum, more than maximum, limit violation will be there. So it has violated, it is lesser than the minimum one, that is 0.2 per unit. So what will be punishment for this bus? it has lost its identity now. Bus voltage specification has now been dropped because of this problem. So it will be which bus? PQ bus. So P will be as it is, and you will write Q2 in this iteration. Q21 as the limiting value. We have discussed this. So that will be now 0.2 per unit. As it has been now treated as PQ bus. So P2 will be this and Q2 will be this. Got the point? So once it is now PQ bus in this iteration, so variables will be V and delta. So you are required to evaluate V21 in first iteration, is not it? So just evaluate following the same procedure as we discussed, how to write this phasor for PQ bus. So this is homework for you. So just evaluate for this second, and this is already PQ, this is already PQ. So evaluate it and we will cross check the values in the next class. Thank you very much.
So in this video we saw a problem on voltage controlled bus in Gauss-Seidel method. So in the next class we will be seeing about procedure and flow chart of Newton-Raphson method and another important question in the university exam. So thanks for watching.